Okay, now a few conceptual questions. If you are towing a car up a hill with a constant velocity, the work done on the car by the normal force is positive, negative, or zero. Okay, we discussed this before. Normal force is this way, my displacement is this way. They are perpendicular to each other, so there is no work done by the normal force. So the work done by the normal force is zero. Okay, now what about the work done by the gravitational force? Is it positive, negative, or zero? Okay, in this case, it is not zero. We calculated something like this before. Now we calculated it though for something going down, not something going up, while this one is going up. Now, so what should we look at? The gravitational force when it is along the vertical, some of it is along the horizontal, and some of it is perpendicular. Some of it is along the incline, some of it is perpendicular to the incline. It is acting both ways. Now the part that is parallel to the incline, as you notice here, is pointing opposite to the direction of motion of the cart. Because it is opposite to the direction of motion of the cart, we know that the work is going to be negative there. Now, what can we say about the work done by this tension force? Now, the tension is parallel to the incline, parallel to the direction of motion, so it should be positive. Now, what about the total work done on the car by all of these forces? Of course, that would be zero because the net work is the work done by the net force, but the net force is zero since we are moving at constant velocity. So the net work should be zero. Okay, another question. We have two marbles, one twice as heavy as the other. They are dropped to the ground from the roof of a building. Just before hitting the ground, the heavier marble has as much kinetic energy as the lighter one, twice as much kinetic energy as the lighter one, half as much, 4 times as much, or impossible to determine. Now the thing that we know, without air resistance, both marbles are going to have the same speed. Okay. If they have the same speed, then the only factor that might affect kinetic energy is going to be the mass. And if you recall, kinetic energy is given by 1/2 of mv squared. If both have the same speed, but one of them has twice the mass, then the only thing that's going to change in here is twice m. Twice m is going to result in twice the kinetic energy. So this is the answer. Okay. Now this promises to be a little bit trickier. A cart on an air track, no friction, that's the meaning of air track, is moving at 0.5 meters per second when we cut off the air. The cart comes to rest after traveling 1 meter. We repeat the experiment, but now the cart is moving 1 meter per second when the air is turned off. How far does the cart travel before coming to rest? Okay. Now, in here, it is moving at 0.5 meters per second. Here it is moving at 1 meter per second. So it is twice the speed. Twice the speed, that means, okay, so we have 2 times the speed. 2 times the speed means 4 times the kinetic energy. Now, why is it 4 times the kinetic energy? Because kinetic energy is 1/2 of mv squared. If I double the speed, that's 2v squared, so it's 4v squared. So that's where the 4 comes from. Now, this is the key point here now. So if I have 4 times the kinetic energy, that means the mechanical energy is 4 times as big. Now here it's the same cart, the same track, so we should have the same coefficient of friction and the same friction force. The force that's going to stop it is going to be the same. And that force is going to expand this mechanical energy. It's going to change it into heat. So in the first case we had EM, in the second case we had 4 times EM. And the same force expanded them. And the way friction force does work is F friction times D with a negative sign, remember, since they are opposite in direction. So if I have 4 times the distance, 4 times the mechanical energy, since F is the same, I need 4 times the distance. So it's going to be 4 meters. Now, what's interesting is you have experienced variations of this question in your life, I'm almost sure. Whenever you took a driving test, they asked you about this question. If you double your speed, if you are moving twice as fast, how much longer is it going to take you to stop? And you see it's going to be 4 times as much. That's why, that's the point they are trying to get you to realize when they ask you that question. They ask it, I took the driving test in 2 states, and in both states they asked the question. Here at Georgia, they didn't require me to take it, so I don't know. But I expect it to be there as well. Okay, now a different question here, but discussing essentially the same topic. We have a spring-loaded toy dart gun. Is used to shoot a dart straight up in the air, and the dart reaches a maximum height of 24 meters. Then the same dart is shot straight up a second time from the same gun, but this time the spring is compressed only half as far as before firing. How far up does the dart go this time? We neglect friction and assuming an ideal spring. Okay, again here we have to think about what's happening here. So mechanical energy at the beginning is going to be mechanical energy at the end. The mechanical energy at the beginning is going to be just the spring potential energy. Now, at the end, the mechanical energy is going to be the gravitational potential energy. So when we had a particular spring potential energy, we get 24 meters. Remember, the gravitational potential energy is just mgh. Now, we compress the spring half as much. If we compress it half as much, remember the spring potential energy is 1/2 of kx squared. If we compress it half as much, that's going to be 1/2 of kx over 2 squared. So I'm going to have this 2 here in the denominator squared. So that's 1/4 of 1/2 of kx squared. So I'm going to have 1/4 of the spring potential energy, meaning I'm going to have 1/4 of the mechanical energy. Okay, if I'm going to have 1/4 of the mechanical energy, I should have fourth of the gravitational potential energy at the end. And the gravitational potential energy is just mgh. M is not changing, G is not changing. So the only thing that's going to bring about the fourth is going to be the h. So instead of 24 meters, I have to have 1/4 of that, which is going to be 6 meters. And that should be my answer.